All right, Kaya, we're solving a system of equations, and I can't explain how to do that before I explain why it is what you're doing and some of the reasoning behind it. So you've got these two equations. They both have an x and a y in them. And so, for example, this second one, x minus y equals 1, if you talk about what a solution for that would be, it would be the combination of an x and a y that would make that equation true. Like 3 and 2 would make that equation true, because 3 minus 2 is equal to 1. So there are lots of combinations of x's and y's. And what we want to find is the combination of x and y that makes both of those equations true. And there's only going to be one combination, one point, one ordered pair that makes both of those equations true. So you said you were struggling with substitution. So both of these two equations are in what we call standard form, where the x and the y terms are on the left, and then the number of the constant term is on the right. So the first thing that you have to do here is solve one of those equations for one variable. All right, so that's the first thing you have to do. Now, it doesn't matter which one you pick. You've got this x, or this y, and you can solve for any of them. I always want to look for the ones that have a positive coefficient, like the number out in front, or even no coefficient. So this has a 2 in front of it, so this has a 1 in front of it, this has a 1, and this would have a negative 1. I'm going to solve for one of these two. It just makes it easier. So I'm going to start with this equation, this second one. We'll call this A. And call this B. I'm going to solve equation B for that x. So I'm going to pull this down there. X minus y is equal to 1. So what I want to do is get this thing by itself. So I'm going to add y to both sides. And now we have this new equation. X is equal to 1 plus y, or you may be inclined to write it as x is equal to y plus 1. All right, so all we've done is rewrite equation B like that. Now here's where it gets fun. Here's where the substitution happens. We now have something that x is equal to. X equals this whole thing, this expression right here, y plus 1. So anywhere we see an x, we can replace it with y plus 1 because they are equal. So that's where we substitute that into the other equation. We find the x right here in the other equation, we take it out and we replace it with what it's equal to. So I'm going to pull equation A down here and rewrite it. 2x plus y is equal to 20. And now I'm going to take the x out and I'm going to replace it. I'm going to replace it in parentheses with that thing, y plus 1. And then I bring down the rest of that equation, plus y is equal to 20. And so what you'll notice now is that in this equation, the x is gone. We only have y's. Now we solve this equation for y. So we distribute the 2, 2y plus 2, plus y is equal to 20. Now I'm going to simplify this left side of the equation. 2y plus y is 3y, plus 2 equals 20. I'm going to subtract 2 from both sides. 3y is equal to 18, and finally we'll divide by 3 on both sides. Y is equal to 6. All right, so the good thing is we have now a value for y. Right, remember I said we were looking for some x-y combination that would be a solution that would make those true. We have the y value. Now we have to find the x value. And here's where we substitute again. So we go back up to any of the equations that we started with, either this one or this one, whichever one looks easier, or often it'll be this new version that you made here. That's the one I'm going to use. I'm going to pull this one off to the side, say x is equal to y plus 1. And because we now know what that y value is, we're going to substitute it right in there. So x has to be equal to 6 plus 1, which is 7. So now we have an x value and we have a y value, which means the solution is that point, that ordered pair, 7, 6. And remember, that thing has to make both of those two equations true. So if we plug the numbers 7 and 6 in here and here, 2 times 7 is 14, plus 6 is 20, and 7 minus 6 is equal to 1. And so those are the only, that's the only combination of numbers that would make both of those true. Now, real quick, you also mentioned graphing. I want to relate this to graphing so you can maybe have even a better concept of what that means. Flip this over, and those graphs would look like, let me see, 2x plus y is equal to, what was it, 2x plus y equals 20. If you're going to graph that equation, you might put that in slope-intercept form. Y is equal to negative 2x plus 20. And I'm just going to do a quick sketch, right? This would look like up here, we'll make this 10, make that 20, and it would have a slope of negative 2. So it's going to look something like that. And then the other equation was x minus y is equal to 1. And if we put that in slope-intercept form, it would look like this. Negative y is equal to negative x plus 1. Divide both sides by negative 1. Y would be positive x minus 1. We would just change those signs. That, if we graphed it, would look something like this. It would have a y-intercept of 0, negative 1, and then a slope of 1. So it would look something like that. Now, what we're doing is, when we're solving system of equations, we're finding graphically the point where those two lines would cross. It would be the combination of x and y that make both of those equations true. And what did we say that solution was? We said it was the 0.76, which is exactly where that would be. Hope that helps.